Hello everyone, I hope you are doing well. In this video, we are going to solve the part C and D of this question. The solution to part A and B has already been uploaded. You can check it out in the solid state physics English playlist. Okay, it's a specific playlist. I will link it in the comment section. You can check it out. So let's see what the part C says. Here we have to draw the HCP structure along the 2 bar 110 direction. Okay, we have to draw this direction in HCP structure, and we have to include the lattice points. Okay, we have to mention the lattice points, the interstitial sites, and the planes that contain those sites. Okay, we are supposed to draw the detailed HCP structure. Okay, and we'll mention the direction 2 bar 110 also here, and we'll see it how we'll do this. And in part D, we are told to write down the Miller indices of the planes that are parallel with 0001 and contain the interstitial sites of the HCP structure. So in part C, we already have drawn the planes. We already would have been drawn the planes that contain. So site, we just have to name the Miller indices. Okay, and all these planes should be horizontal. For example, as the 0001 plane corresponds to a basal plane, so they will be parallel to the basal plane. Okay, above the basal plane, just like parallel, we'll see it. Okay, after that, now let's start the problem. So first of all, we have this direction to part 110 direction. Okay, and we have to draw this direction, and for that purpose we can see here that h here is -2, k, these are the Miller indices of the direction. So it's h, it's k, it's I, and it's l. So k is 1, I is equals to 1, and l is equals to 0. We have to convert them into a 3-digit Miller index. So h prime equals h minus I, k prime equals k minus I, and l equals l prime. Okay, l prime equals l. So h minus I, here h is -2, minus I is 1, so it gives -3. Okay, after that we have k prime equals k minus I, k is 1, minus I is 1 again, so 1 minus 1 gives 0, and l equals l prime. So here l is 0, so l prime will be equals to 0 also. So we got -3, 0 and 0, okay, in square brackets. In that one case I just took the round brackets just to so I cut this part of the video. -3, 0 and 0, and we know that we can divide the Miller indices of a direction by a integer, a positive integer, to reduce into a lowest integer, and that integer should be positive. You cannot divide it by a negative number. This operation is not allowed, so we'll divide the three numbers by 3. -3 by 3 gives -1, 0 and 0. Okay, and we can write it as 1 bar 0 0. So this is the direction. Okay, and we'll draw it in HCP. The first one is for A1, the second one is for A2, and the third one is for Z. And we can see here that only A1 is non-zero here. So let me draw the HCP basal plane. Okay, and I will draw the 2D representation. It is because it's very tough to draw the HCP structure in 3D and to visualize the positions of different atoms in it. Okay, it's very tough because in this problem we are told to mention the interstitial sites also, and the involvement of interstitial sites in a HCP structure makes it complex in terms of like understanding and differentiating between different atoms, like where they are located and all that stuff. So I'll give you some hints to remember that structure. It is because it's very difficult to visualize it. Okay, so let me draw these triangles. These triangles helps a lot. Okay, these triangles should be straight, try to make them as straight as possible. So yeah, let us first draw the direction. Okay, and after that we'll draw the lattice points. Lattice points are actually the actual atoms whose HCP structure it is. Okay, whose crystal is has this structure and all that stuff. Means these are the lattice points are the main atoms, while interstitial sites are the extra atoms that just fit into the structure. Okay, illegally. So let us call this axis as A1, this one as A2. Okay, a3 is not allowed. a1 is -1, so this is positive a1 direction, so this one will be the negative a1 direction. So negative a1, a negative 1 means we have to move 1 unit along the negative a1 axis, so it means this is the final point, and no movement along a2 and z, so this is the final point, and this vector in this direction, you can also mention it like that, like this direction. Okay, the position of a vector is always irrelevant. It is because any integer multiple of the vector will be that vector. Okay, as we saw here and use this property. So you can mention the vector direction here, this direction in this way. Okay, this way is this direction. Okay, which we were told to draw in HCP structure. So this is the 2 bar 110 direction. Okay, now let us draw the atoms. Okay, there will be atoms located at each of the corner points. Okay, and all these atoms touch each other. Okay, this is what actually happens, but we'll try to connect them as much as possible. So like that, and okay, I'll attach the picture of accurate atoms where which has computerized um, diagram of this whole stuff. Here I'm just explaining the position of atoms. All right, so this is the basal plane. These are the atoms in the basal plane, and the basal plane is 0001. Okay, we already know about it, that the HCP structure. Let me show you. This is a simple HCP structure which does not show any presence of interstitial sites. Okay, the interstitial sites representation is not here. It's the simple HCP structure. So this is the basal region. It has the Miller indices 0001. Then there is a central plane. Okay, for the lattice points. These are the lattice points. Okay, only lattice points are represented here. So this is the basal plane, and this plane is 0001, and this is the centermost plane, and it has the Miller index 0002. Okay, and above that plane there is this one plane again, which is totally similar to the basal plane, and that's why it has a similar Miller indices 0001. Okay, because they form the family of the plane. They both are equivalent. Okay, so this one plane has the lattice sides. Okay, the roof plane, and it has the Miller indices 0001. Okay, and this is the 0001 plane again, and this is the 0002 plane. So the lattice sites will be located at 0001 and 0002 planes. Okay, this information will be helpful in the later problem and also in this one. Okay, here we have only represented the basal plane. So we can see here in the middle plane there are the three atoms. Okay, and they are located in these positions. Okay, so we'll draw these atoms by some other color. Okay, I'm first drawing the lattice points, and then after that we'll draw the interstitial sites. Okay, so here be the one atom. These are the three atoms. Okay, on the 0002 plane, so we have to draw them also. And here is the third one. Okay, so these are the three atoms. You should have markers of different colors so that you can differentiate between different atoms. Okay, so here the blue circles are the atoms on the basal plane, and also atoms on the roof plane. Okay, and I'm not doing them again. It is because they are similarly present on the roof plane too. So what I will do to show that I have drawn the atoms both on the basal plane and the roof plane, I'm circling some part of it so that the other unshaded part appear as the reflection or something like that stuff. I think you are getting my point, that I have successfully drawn all of the lattice points. Okay, that way um, this this one circle is the atom in the basal plane, this one, okay, and this one, okay, that contains that unshaded part also. Then comes the second plane 0002, which has these center atoms, okay, and then comes the roof plane, which has this part of the atom, okay. Just differentiate because they are just appearing right above the basal plane atoms, okay. So this is the diagram till now. Now we need to mention the interstitial sites. We know that there are two types of interstitial sites. Interstitial sites named as, there are two types of interstitial sites. One is the tetrahedral sites, and another is octahedral sites, okay. Interstitial sites are the sites where the foreign atom can just adjust itself, okay, illegally. So they are the two types of sites that they can occupy. One is tetrahedral site and another is the octahedral site. How we determine their positions and how we draw them properly, the video to this thing will be uploaded separately, because for now we are doing the problem and I cannot um, spend much time on explaining how to find out tetrahedral and octahedral sites. I'll just directly mention here, but I'll give you the hints in order to remember where their locations will be. In that respect, these triangles helps a lot, okay, so do remember them. Tetrahedral atoms are located on the plane 0008, okay, and the octahedral atoms are located at 0004 plane. The plane where the tetrahedral atoms are located is 0008, while the plane um, where the plane and the family of the planes where the octahedral atoms are located is 0004, okay. And in HCP structure, there are two planes where octahedral sites are located and four planes where the tetrahedral sites are located, okay. So this is a later thing, it's not needed right now. um, Now let us draw the tetrahedral sites. So tetrahedral sites are located at 1, just above these atoms, okay. We represent it with smaller circles, okay, just above the lattice points they are located. All right, and also here. Do remember that there is a lattice site at center atom here also, a blue line, okay, which I have not shaded because I was going to draw the other atoms, so yeah. Okay, I have successfully drawn the tetrahedral atoms just right above the lattice sites, okay, and other than that there are three other locations where they are located, okay. One at the center of this triangle, two at the center of this triangle, leaving one triangle behind as empty, leaving this triangle empty, this one at the center of this one triangle, okay. So here the blue lines, the blue circles are the tetrahedral sites. Now we are going to draw the octahedral sites. And just like lattice atoms, the tetrahedral planes are repeated. So there will be some additional sites, tetrahedral site just right above these sites, okay. just like I mentioned here that they are atom just right above here, so in 2D diagram they just appear right above this atom. Okay, so these locations are actually doubled and tripled also. Now let me draw the final site, which is the octahedral site, and the octahedral site is here at the center of these empty triangles. Okay, all right, so this is the diagram. Okay, and let us now um, mention the plane where these sites are located. And the size of the octahedral sites will be larger as they are lesser in number, but they manage to fit an atom of bigger size, while the tetrahedral sites allows smaller atom to be to be there and occupy that site. Okay, while the largest atoms are actually the lattice atoms. Okay, additionally do mention in the paper that the blue atoms show the lattice points, the red atom shows the octahedral atoms, octahedral sites, which are actually the interstitial sites, and green shows the tetrahedral sites. Tetrahedral sites. You know the spellings, okay? And this color, I don't know what color it is. You should use the color whose name you know. So let us call this color as brown. So blue plus brown lattice points. Okay, just to differentiate the position I will use the different color. Now let me draw the planes. Okay, so first of all I'm drawing, just remember the pattern in which I am drawing these planes. It will help you to remember the planes. Okay, so this is the basal plane, okay, which I will call it as 0001. Okay, the similar diagram is needed in the part I think it's part D or part 4. The similar diagram is needed, so I'm doing it just once. It is needed in part C also without Miller indices, and the similar diagram is needed with Miller indices in part 4. Okay, I'll properly write something in part 4. Okay, I'll do that, but the figure will be same in both the cases. It's up to you if you leave it. So it's 0001 basal plane. Okay, and after that we know that there is a center plane which is 0002. Okay, which has these atoms, okay, these brown atoms in it. Okay, and the last plane in HCP which contains the lattice sites is 0001 again, which is the roof plane. Okay, I'm calling it as a basal plane, a center plane, and the last plane which contains the lattice sites. Now the figure here and here will be actually the mirror image. Both of these will be same. So then comes the tetrahedral sides, and they are the two planes in between these two planes where we'll have the tetrahedral sides. Similarly here and here, and after that there is one octahedral side, okay, in between them, and also one octahedral side in between the tetrahedral. These are the horizontal line shows the plane. Okay, they are representing planes, nothing else. Now let me draw the atoms now. Okay, here I have drawn the longer lines. It is because the previous diagram would have been very short, so that is why I am doing it with the longer lines to you should do the same. Okay, these lines should be longer so that many atoms could adjust and the location could be more clear. So first let us draw some blocks. Okay, let me draw one atom here. Okay, we'll draw 3 atoms at least per line. So let us make this one block. It will be for second. tetrahedral, octahedral, then again this one atom. Okay, two blank lines, and then the last again this atom. Okay, you should have two lines in between these two atoms. Okay, now these are the atoms on the basal plane, and we know that the roof plane has the atom at the similar location, so we'll draw these atoms at the similar location. All right, and we know that in 0002 the atoms are not located right above to the basal plane atoms and the roof plane atoms. They are located somewhere next to them. Okay, somewhere next to them, so I am drawing them on the next column to their location. So second will be located somewhere next to them, and for this we don't need to because the column is missing, so two atoms will suffice. Now we'll draw the the tetrahedral sites, and we can see here the tetrahedral sites are of two types. One is just right above the lattice atoms, okay, and the other is somewhere next to the lattice atoms. Okay, so first comes the ones that are next to the lattice atoms, and it will be here. Okay, next to lattice atom it will be here. All right, and next comes where they are located just right above the lattice atoms, which is this location, this location, this location, and the similar trend is um, repeated downwards, but like that, um, just right above, just right above, because they are the mirror images, and here, yeah, and here. Okay, so these are the locations of the tetrahedral sites. Now we are going to draw the octahedral sites, and octahedral sites are located beyond these tetrahedral sites, like here and here, in similar location. Their locations will not be changed. Okay, so these are the planes that contains those sites. Okay, these planes contains the lattice sites, these planes contains the tetrahedral sites, and these two planes contains the octahedral site. And let us call these planes now. As I told earlier, the tetrahedral sites are located at 0008 plane. Okay, and the octahedral sites are located at 0004 planes. Okay, this figure was needed in the part D. Okay, in part D you have to write something other than that diagram also, so you can draw the similar diagram in both the parts. Okay, in part D we have lattice sites or lattice points located at both L is equals to 0 and L is equals to 1, which corresponds to L is equals to 0 and L is equals to 0, which is the basal plane, L is equals to 1, which is the roof plane, and L is equals to 1 by 2, which is the middle plane. Okay, with planar Miller indices triple zero one and 0002. L is equals to 0 and L is equals to 1 have the same corresponds to a same plane, and they will be represented by similar Miller indices. Okay, 0001, and the middle plane is represented by 0002. Okay, these are for the lattice sites. Now for the octahedral and tetrahedral sites, the tetrahedral sites are located at L means the position with respect to z-axis, because they are located at some height, you know. Their tetrahedral sites are, you can see here, they were the four planes now where tetrahedral sites were located. Okay, so and the position with respect to is L is represented in terms of the inverses. You can see here the index was 2, but L value was 1 over 2. Index is 1, the value is 1 again, because reciprocal of 1 is 1 again. So as we can see here, the Miller indices contains 8 here for tetrahedral sites, so the position with respect to L will be our A type. Okay, and it will be the odd multiple of it, 1 by 8. This will be this will be 1 by 8, the other one will be 3 by 8, 5 by 8, 7 by 8. Okay, and these are the locations of tetrahedral site with respect to the z coordinate. With they will be located at this position on planes with Miller indices, but all of these planes will be having the similar Miller indices, 0008, parallel to, because we were told to draw the planes which were parallel to this plane. Okay, that is why we considered only 0008 type of thing. Okay, and the octahedral sites, correct your spellings, okay, are located at two z locations. Okay, one is this and the other one is this. It is 4 here, so they will be our 4 something. Okay, 1 by 4 and 3 by 4. Okay, and with on planes with Miller indices 0004, parallel to, as shown in figure, let's say B. Okay, and you have to draw this figure again with these planes representation with them. So this is figure B. Okay, do mention that this is lattice atoms, these are the tetrahedral atoms, sides, and these are the octahedral sides. All right, so in that way the question is done.